Today's lesson is on section 5.3, write linear equations in point-slope form. First two sections of this chapter, we've also written linear equations, so that'll be nothing new, but we are going to learn a new form today to put these equations in, and it's called point-slope form. First, I'm going to talk about the other two forms that we have already worked with this year, and so we'll know three forms of linear equations that we can work with. And as I'll talk about though here, I've got them in order of popularity. The very first form I'm going to talk about, number one, is again the one we use so much to graph. We have two different methods we use this one to graph for. When we're making equations, that's the one we've been using most commonly so far. Slope-intercept form, and again that looks like y equals mx plus b. When you think about linear equations, this is the main form that comes to mind because this is the most basic form they set up in. Usually there's some kind of slope, and then you can find the y-intercept, and that'll be important information in a problem. And so many problems set up well with slope-intercept form, and it's usually one of the easier forms to put together, one of the most useful forms as well. Again, the two important things we need in slope-intercept form are the things that are right in the name. The slope, m the slope, and b, which is the y-intercept. So again, a nice thing about the name of each of these, of a couple of these, intercept, yep. The nice thing about the name of a couple of these forms is that the name tells you what the two important pieces of information in them are. Slope-intercept form, the important things are the slope and the y-intercept. If I know the slope of the line and the y-intercept of the line, I can make that equation. Keep that in mind when we get to talking about point-slope form here today. Method number two, or sorry, not method number two, but form number two that we use a lot is standard form, and we use this back in chapter 4 to graph with intercepts method. Again, the biggest thing just to notice about standard form, how does that look different than slope-intercept, is that x and y are on the same side of the equation. You can use whatever variables you want here. They have a, b, and c there, capital A, B, C. But I guess it doesn't matter what those are just numbers, constant, and two coefficients. But the main thing to notice is where those independent and dependent variables are. Here's x, here's y, and they're on the same side of the equal sign in this case. So it's for something to be in standard form, I need the term with x and the term with y to be on the same side, and some constant on the other. Well, again, those two forms we use quite frequently when we're talking about linear algebra, especially slope-intercept form. That one comes up all the time when we're making problems. Standard form too, we don't really make a lot of equations in standard form. But when it comes to word problems, there are some word problems that set up best in standard form, and that's when that'll be most helpful for us. Well, again, there is a third form, though. We're going to talk about a third form here today, and it's called point-slope form. And here is that form in red here. Again, if you're taking notes along with this lesson, then make sure you copy down the first two things that were in red there on the previous page, slope-intercept form and standard form. Make sure you copy these down as well. But here is, I guess you'd say, form number 3, point-slope form. And here's what it looks like. It says y minus y sub 1 equals m, and then in parentheses, x minus x sub 1. What are those sub 1 and sub 1s for with the x and the y? It's kind of like when we talk about finding the slope of a line. Those are just places that we're going to put coordinates in. We saw this in the slope formula. We had x sub 2, x sub 1, y sub 2, y sub 1, those numbers that we subtract. Okay, that's where we put the coordinates in when we have a point to deal with in point-slope form. Okay, so sorry, going to cover everything up, but going back to the form here. When I have coordinates that I'm going to put into point-slope form, that's where they're going to go in. Think about slope-intercept form. In slope-intercept form, the two easy things to identify were the slope and the y-intercept, like I talked about on the previous page. In point-slope form, there are two things that I need. A point, some point on a line, and the slope of the line. The slope still goes in a similar spot like we've dealt with before. That's still m, so that's going to go in there if I'm going to make an equation in point-slope form. The point, like I was talking about a second ago, the x and y coordinate, they're going to go in for x sub 1 and y sub 1. This is where I'm going to put those in. So if there's some point, like let's say it's, 3, 5, then I'm going to put the 3 in here, and I'm going to put the 5 in for y, and then I'll be able to put the slope in and make my equation in point-slope form. So maybe one more thing to note. I'm going to have you one more thing with this, with point-slope form here, with the actual with this page, is you could put something like, it's kind of not formal terms, but this is where those x sub 1 and y sub 1, this is where the coordinates go in. When I have a point and I have a slope, I can make an equation in point-slope form, because again, those are the two things in the name. And the slope's going to go in again where it usually would, and the coordinates are going to go in for this x sub 1 and y sub 1, those two places. Now, like I mentioned on the previous page, I kind of had these equations in order of how often we use them. So notice that point-slope form is the third one on this list. There's nothing wrong with point-slope form. Okay, it definitely models linear equations. If I have a point and a slope, it's the very quick equation that I can make. The only trouble with point-slope form is we just don't use it a lot at this level. We use slope-intercept form a lot more. Again, problems set up easier with slope-intercept form, and they often they just make more sense in that form. Usually B is like a starting point, like some kind of initial phi or something. A lot of the problems we see set up nice with a slope and with just a y-intercept, some kind of rate and some kind of starting point. Okay, point-slope form, again, there's nothing wrong with it. We just don't use it that often. We don't see it that often. So I'm talking about this as the third one. The reason why I am still going to teach it, though, is it is an MCA standard. It is something that I guarantee students will see at least a question or two about it on the MCA test. And if those are one or two questions more that they can get right and have a chance of passing their test, then so this is something that I want them to know. So we'll talk about point-slope form for just a day or two here, but it is still something that I want them to have be aware of and be in the back of their mind. For point-slope form 2, one more thing to keep in mind is it's not like we'll just talk about this one day and then they'll never see it again. One nice thing about the MCA test is they do have a formula sheet, as I'm going to bring up here. Here's the formula sheet that a student might see when they're taking the MCA test. They can click on a button and it'll bring these formulas up. And notice here is point-slope form along with some of the other ones we talked about, slope-intercept form and standard form. So if a student is going through the MCA test and they read a question that says put equation in point-slope form, okay, and they think, oh man, I forgot, what does point-slope form look like? Well, they just click on the formula sheet and here it is, just like we're talking about today. There's point-slope form. So again, it is important enough to talk about. It's not the most frequently used of the three linear forms of an equation, but it's still one I want them to know because it will help them get some problems right. And if they kind of at least can keep in the back of their mind and reference it then when they see the name point-slope form on the formula sheet, that can help them remember what should it look like and how to put an equation together in point-slope form. Let's look at a couple of examples then. What might it look like making an equation in point-slope form? Directions might say something like this: write an equation. Use that form. Again, what do I need in point-slope form? Is just a point and the slope. If I know the point, some point that line goes through, and then the slope of that line, then I can make an equation that looks something like this. This first problem says the slope of the line is -3, and it goes to the point 4, 1. So in this case, again, if we just start doing things like we do with slope-intercept form, I can say, well, do I have my slope? Well, yeah, I do. In this case, I have -3. That's my slope. And do I have a point? Yeah, I got the point 4, 1. As long as I have those two things, I can make an equation in this form. So I've got all I need. All I got to do is plug them in the right spots. In this formula, the y-coordinate goes in for y sub 1, the x-coordinate goes in for x sub 1, and the slope goes in for m. So it looks like y minus 1 equals, my slope is -3, x minus 4. And again, it looks a little bit goofy there, because again, the coordinates are +4, +1. But when you put them in this particular form of the equation, it ends up being -x minus 4 and y minus 1. As students are going to find out later in their high school careers, there's other formulas in calculus, in quadratic algebra, other formulas that do something like this. And so if nothing else, maybe it'll be a little bit of introduction to those formulas. But those are ones they won't work with as much anytime soon. So, but it is something that is one reason why it is a useful type of formula. So as they'll see when they get older for graphing, some formulas set up like this where the variable, where they have something like x minus 1, y minus 1, and that can tell you some points on that particular line. So something they will see in the future. For now, point-slope form, we want to know about it. Not the most popular form, though, we're going to use all year. Just something to keep in mind. Let's go on to problem number 2 here. This one says the slope of the line is 1/3, and the line goes through this point, -1,9. And again, students, I always encourage them, okay, they can make a little graph of this too if they're having trouble just visualizing what does this look like. Nothing wrong with making a graph of it. The point -1,9, well, that'd be left 1 and then up 9. 4, 5, 6, 7, 8, 9. Go up a little farther than I made my axis here, but so -1,9, there'd be that point. And then a slope of 1/3 would be up 1 and over 3. So maybe the line might look something like this. Okay, again, if it helps to draw yourself a picture just to see it, go ahead. I mean, that's some people are visual learners. That may help them a little bit when they're making the equation, or just to get a nice sense of what's going on with this line. So the slope is 1/3. So this is my m. I got my x and my y coordinate right here, -1 for the x coordinate, y coordinate is 9. So when I start making this equation, I can just do it right now. Y minus 9 equals, slope is 1/3. And then here's the part that keep in mind, I guess, for point slope form. There's one tricky part. It's this. When I put -1 in for the x coordinate, this is still subtraction. So it ends up being minus -1. And so like we often do, if I see minus and negative, we'll do a chop here, and really it's like x plus 1. So again, there's not too many tricks to point slope form. As long as you have a point and a slope, you just plug them in and make your equation. But one thing just to keep an eye on is when you have a negative coordinate like this, when you plug it in, it'll end up being like chop. It'll look like plus. If your x coordinate's -1, like you see here, it ends up looking like x plus 1 in the formula. So just something to keep in mind. This third problem here, in this one, I don't have the slope of the line. You know, if I usually would start saying, okay, if I'm going to put something in point slope form, do I have the slope? In this one, I don't. It says the line goes through these 2 points, 2, 0, 0, 2, and 5, -4. Well, I don't have the slope, but we should remember, if we have 2 points, we can always find the slope of the line. You could make a little graph for yourself, or we can do the subtraction where I take 2 minus -4 and 0 minus 5. 2 minus -4 on the top of my fraction, 0 minus 5. I get 6 over -5, so that's just a negative fraction, like -6 over 5. There's my slope. And now I can use, again, both those points are on the line, so even in point slope form, it doesn't matter which point I use. As long as I pick one out, I can make an equation in point slope form. So I'm just going to pick out this one here. I'm going to pick out 5, -4 in this case. And so when I start writing my equation, again, it'll be y minus, well, here's my y coordinate, y minus -4. So think right away, it'll be chop. This will end up looking like y plus 4 equals, my slope is -6 over 5. And then in parentheses, x minus 5. There's my equation in point slope form. One more thing I would want students to be able to do with point slope form is to take that equation and be able to make a graph. Hopefully they can take some information and make an equation like we were doing on the previous page. But also you should be able to kind of interpret the formula and say, okay, where's a point that this equation goes through, or this line goes through, and what's the slope of it? They should be able to pick those things off a point slope form. Again, here's the form. Y minus y sub 1 equals m times, in parentheses, x minus x sub 1. So if I'm looking at this formula, or this equation right here, you should be able to pick off that key information. First of all, the slope is just that number right in front of the parentheses. So the slope is -2. And then if I'm going to pick out a point, well, the x coordinate will be over here by x. So in this case, realize it says, again, plus 4. But in this type of formula, when it's supposed to be x minus whatever the x coordinate is, realize that if it says x plus 4 in this spot, my x coordinate is actually -4. Because how that would plug in, it would be x minus -4 if you were actually making the equation. And then you'd have to chop and get x plus 4, which is what I got up here. So just kind of realize that's why it ends up looking like, or actually like I got up here. So realize that's why it ends up looking like that, but really realize that that's why the x coordinate is actually -4 when I get it from the equation. Okay. If I keep going then, looking at the y over here, it says y minus 2, but again realize That's what the formula is supposed to look like. It's supposed to be a subtraction sign there. So this is just 2 as my y coordinate. Once I've got a point and a slope, I can make a graph of just knowing this information and what the line looks like, because I know it goes through this point. I know the line goes to this point and it has this type of slope. That's all I need to make an equation, or sorry, to make a graph. The point -4, 2 would be left 4 up 2. So there's that point. And then the slope is -2. That's like -2/1. So down 2/1, down 2/1. There'd be the graph of that line. Again, I picked out the key information in point slope form. Picked out the point. I picked out the slope. Once I add those two things, that's all I need to make a graph of that equation. I'll do one more example here for you. Again, here's an equation in point slope form. So those are the two key things that I can pick out. I can pick out a point, and I can pick out the slope. Where's the slope in this form of the equation? It's just the number in front of the parentheses there, so my slope is 5. If I'm going to pick out a point, again, it's the numbers that are right next to the x and y here. And again, remember, in point slope form, as I pointed out on the previous page, it's actually supposed to be y minus whatever the coordinate is, and x minus whatever the coordinate is. So when I come back to my problem and I see that it's plus, the way that it would end up being plus is if it was x minus -6, chop, chop, and then that's when I'd get x plus 6. So in this case, I should know that the coordinate is actually -6 for x, and same thing here. This is y plus 1, so really the y coordinate, the point that I'm looking for, is -1. Once I've got the point and I've got the slope, I can make a graph of this line. It goes through this point for sure, is what I'm saying. So -6, -1, where is that? Left 6, down 1. And then I have a slope of 5, which is like 5/1. So up 5/1, up 5/1. There's my line. Again, using point slope form, and not too bad. I think it's something that just after a little bit of practice, we can kind of get used to and see how that works. And just something to kind of, the form of the equation, again, it's not the most popular one, but one to keep in the back of our mind because we are going to see it again on the MCAs. It may help us just get a few questions right, but then that means it's worth it. If it gets us a few more points on the MCA score, then it's worth at least knowing.